This is connecting FF prime, F double prime example 3. We're going to just read some information from a table, practice reading from a table. So we have a function f which is continuous on the domain, -2 to 4. F prime and F double prime have the following properties in the table. So just make sure you're paying attention that this line is your F prime line, and this is your F double prime line. And we have some intervals that are given to us. So we've got all of these intervals across the top here, and we need to figure out some questions based off of the information from the table. So at what values of x does f have critical numbers? Well, remember, f has a critical number anytime f prime of x equals 0 or is undefined. So where do we have f prime of x equaling 0 or undefined? We had that happening here at x equals 0. It doesn't exist. And we also have at x equals 2, the derivative equals 0. So my critical numbers are at x equals 0 and x equal 2, where the derivative is undefined or doesn't exist, or the derivative equals 0. And then we want to classify these as relative mins or maxes or neither. So if you notice, we start out with a positive derivative from -2 to 0. So the function is increasing. Okay, the function is increasing here. And then the derivative doesn't exist, but then the function is decreasing right on the other side because the derivative is negative. So it probably looks something like this. If I was guessing, it would look like this. Okay, the function is increasing, but there is no derivative, and then the function is decreasing. It could be a cusp, it could be other shapes as well, but it's going to be something like this because there's no derivative there. And then at 0, it's decreasing, but then it continues decreasing on the other side of 2. I'm sorry, at 2, where the derivative is 0, the function is decreasing, and then it continues to decrease. So it's probably going to look something like this. At x equals 2 would be the shape of that graph. So I would state that x equals 0 is a relative max because f prime changes from positive to negative, and x equals 2 is neither a min or max because f prime does not change sign. Okay. Second question asks us, at what points does f have a point of inflection? Justify your answer. We can have a POI anytime f double prime of x equals 0 or is undefined / does not exist. So that's going to happen at, again, x equals 0 and at x equals 2. So we have possible POIs at x equals 0 and at x equals 2. But don't forget, f double prime of x also has to change sign, okay, in order for us to have a point of inflection. So at x equals 0, it doesn't change sign because we go from positive, which is concave up, to positive, which is concave up. So x equals 0 is not going to be a point of inflection. But at x equals 2, we go from concave up to a negative second derivative, which means we're going concave down. So this one would be a point of inflection. And, it's going to look like this, concave up and then concave down. So therefore, x equals 2 is a POI because f double prime of x changes sign. Doesn't really matter if it changes sign, positive to negative or negative to positive. It's still going to be a point of inflection. And then finally, on what intervals is f increasing? F is increasing. F increases when f prime of x is greater than 0 or positive. So when does that happen? That happens from -2 to 0, and that's it. That's the only time f is increasing, only when f prime is positive. And then on what intervals is f concave down? F is concave down when f double prime of x is less than 0. And let's see when that happens, or negative. That happens right here when the second derivative is less than 0. It looks like that happens from 2 to 4. So 2 to 4 is my final